Math Buhay and welcome to DepEd TV. This is Mathtivated for grade 11 General Mathematics. I am Teacher Carol and there's nothing too big or too small because we will learn it all. So keep Mathtivated and stay with me because we are together in this wonderful journey. How have you been? I hope that you are doing well at home and enjoying your tasks and assigned activities. It is another day and we will be sharing another interesting discussion. Before jumping to the meat of today's episode, let us have a very quick brain teaser. This is in Roman numerals. The expression you have, xi, which is 11, plus ii, which is 2, is equal to ix, which is 9. And we know that 11 plus 2 is not equal to 9. Now, I want you to think of a way to make this right. You have 10 seconds. Your time is over. If we will have this upside down, this will be xi, which is 11, is equal to ii or 2, plus ix with a value of 9. It makes sense now, right? 11 is equal to 2 plus 9. Did that make you mathtivated? Let's keep going then. This is just a practice to check how well you reason out or you being rational. It is defined as having reason or understanding. According to Proverbs 2 verse 6, all wisdom comes from the Lord, and so do common sense and understanding. Since we are given these gifts, we are also given the opportunity to do what is right in any situation. And I want you to keep that in mind for you to be motivated in being a righteous student. Let's now go to rational as used in mathematics. When we speak of rational in math, we deal with ratio, which is a comparison between two values. It can also be written in the form of a fraction, and that will be the focus of our episode today. Because by the end of this episode, you will be able to represent real-life situations using rational functions, distinguish rational functions, rational equations, and rational inequalities. Solves rational equations and inequalities. Represent a rational function through its table of values, graph, and equation. And find the domain and range of a rational function. Let us start by checking on the following expressions. Let us match the following expressions if it corresponds to a rational equation, a rational inequality, and a rational function. You have 10 seconds. Your time is over. Let's check your work. Let's have them one by one. Why is it that 2x over 1 minus x equals 1/4 is a rational equation? Is it an equation? Yes, it contains an equal sign. Does it have a rational expression? Yes, 2x over 1 minus x equals 1/4 a rational expression. Thus, we say that rational equations are equations that contain rational expressions in one or both sides of the equation. How about a rational inequality? If a rational equation is an equation containing rational expressions, then a rational inequality is an inequality containing rational expressions. Our given contains a greater than symbol, which is an inequality symbol. It also contains rational expressions, which are -2 over 1 minus x is greater than 1 over 2x. For our next one, the expression x over 3x plus 1 equals y is a rational. But what function? A rational function is a function of the form r of x is equal to p of x divided by q of x, where p of x and q of x are polynomials and equal to 0. Why do you think it is important to note that the denominator should not be equal to 0? Because 0 will make the value undefined. X and 3x plus 1 are polynomials and are expressed as ratio, and it is equal to y, another notation for f of x, then we say that this is a rational function. We just have finished distinguishing rational equation, rational inequality, and rational function. Still motivated? Let's continue. Solving the rational equation and inequality. Having the equation 2x over 1 minus x equals 1/4, we can have the product of 2 will be equal to the product of 1 minus. Where did we get this? Half can be written as a proportion. So it can be written as 2x is to 1 minus x, which is equal to 1 is to 4. And recalling our lesson in proportion, the product of the means is means. In here, we make times 4 equals 1 times the quantity 1 minus x. 8x, and 1 times 1 minus x. We'll have 8x equals 1 minus x. Let us solve for x. By addition property of equality, we add positive x to both sides of the equation for us to have 8x for the inequality. We take any value in C to test in the inequality. Let us have 3. We use it in the given inequality. That is 3, 1 all over 2 minus 3 is less than or equal to 0. 3 plus 1 is 4. And 2 minus 3 is negative 1. 4 divided by negative 1 is negative 4. Since negative 4 is less than 0, then C is a set of solutions for the inequality. We then combine all the solutions for the inequality. X plus 1 all over 2 minus x is less than or equal to 0. In the meaningful numbers, x equals negative 1 and x equals 2, only negative 1 is a solution. In the intervals a, b, and c, only a and c are sets of solutions. Thus, the solutions are x equals negative 1, interval a, and interval c. Combining all this, we will have the set containing values from negative infinity to negative 1, where negative 1 is included, union with the set containing values between positive 2 and positive infinity. That is solving rational inequality. We did it! Your efforts are being counted. Let us now try this situation. The pandemic brought a challenge in the educational system of our country. Schools have to offer distance learning modalities. Students will be kept responsible of their time for academic works at home. Thus, a student who chooses asynchronous distance learning has to budget his or her time to accomplish tasks efficiently. If a student has to spend 40 hours a week for academic tasks, and he or she has X number of subjects, represent the time a student has to allot for one subject. Since the student has time is up. Let's check your work. For x equals 5, we divide 40 by 5. and that gives us 8. For 10, 40 divided by 10 is 4. The third value, 40 divided by 15, is 2 2/3. And lastly, 40 divided by 20 is 2. How many correct answers did you get? Well done if you got them all correctly. But be reminded that your effort is a big part of every single thing you do. So let's continue being motivated. Now, let's try plotting the following points and draw a graph that will pass through these points. The first point is 5, 8. So from 0, we go 5 units to the right and 8 units going up. That's our first point. The second one, we have 10, 4. That is 10 units to the right of 0 and 4 units above 0. The third point is 15, 2 2/3. So we'll jump 15 units going right from 0 and 2 2/3 units above 0. And for our last point, we have 20, 2. This is 20 units to the right of 0 and 2 units above 0. We can now connect the points to create the graph of our function f of x equals 40 over x. And there, we have the graph of a rational function. You did great! We were able to represent a situation using a function, which is also an equation. We also represented it using a table of values and a graph. Let's now check the domain and the range of our function f of x equals 40 over x. How do we represent a rational function again? A while ago, we have learned that a rational function is represented by r of x equals p of x over q of x, with the restriction that q of x should not be equal to 0. So in our function, the denominator, which is x, should also not be equal to 0. Again, this will give us an undefined value. Thus, we can say that a domain, or the set of all possible values of x of the function f of x equals 40 over x is the set of all real numbers except 0. This can be written in this set builder notation, which is one way to write the elements of the domain. Let us now move to getting the range of a rational function. But before going to that, let us recall ideas on inverse of a function. We say that a domain of a function is equal to the range of its inverse. Also, its range is equal to the domain of its inverse. So for us to get the range of this rational function, we have to get the domain of its inverse. And we know that this can also be written as y is equal to 40 over x. To get the inverse, interchange x and y. This will give us x equals 40 over the inverse function. We then solve for y. Let's try it. Since this is an equation, we may use the process in solving a rational equation. X can be written as x over 1. We can start now by multiplying x and y, and 1 and 40. This will give us xy equals 1 times 40, or simply 40. We want y alone on the left-hand side of the equation. Thus, by multiplication property of equality, we may multiply both sides of the equation by 1 over x. Thus, the inverse of the function is equal to 40 over x. This can also be written as the inverse of f of x is equal to 40 over x. Again, the domain of the inverse of the function is the range of the original function. Thus, the domain of the inverse is the range of the function f of x equals 40 over x. We use the same restriction that the denominator should not be equal to 0, since this will give us an undefined value. So the range of the original function is the set of all real numbers except 0. Written as the set containing all y's element of the real numbers such that y is not equal to 0. You may watch this episode again because your efforts really matter. Be reminded that you are doing a good job as long as you take a step and put an effort to learn. Great job! We were able to accomplish all our objectives today. Your efforts in listening and understanding the lesson are very much appreciated. That's a job well done. Of course, I want to know how well you understand the lesson. So in 3 sentences, write your most significant learning today. You may post your works on your Facebook accounts and use the hashtag MathTivated_E2. I had fun being with you, my Mathtivated students. I hope that you also did. Again, this is Teacher Carol reminding you that what others can do, you can too. So let's grow our efforts for us to grow our skills and knowledge. See you in our next episode.